Hello everyone, today I'm going to show you a project. I call it a MOSFET Electroscope. It detects electrical charge. So in a very dry day, we all experience by some means that our body can be electrically charged. For instance, if you are sitting on a sofa and wearing woolen or polyester cloth and you are standing up, you'll see that your body will be electrically charged. And now if you're touching any doorknob or any other metal object, you'll feel an electrical shock. So this MOSFET electroscope, it can detect those kind of static charges, not only human body, but any other electrically charged object. So I'm going to explain how it works. This is the photo of the MOSFET electroscope. When two insulators, like two plastic sheets, come into contact and then separate, we can see that one of these becomes negatively charged and other one positively charged. One gains electrons and other loses electron. The same thing can happen with the metal insulator case. However, it never happens in case of metal-metal contact, as electrons are freely moving. During separation, free electrons flow and neutralize the charge. In everyday life, especially on a very dry day, we usually observe that our body is either positively or negatively charged, and as a result we experience electrical shock quite often. These are not fatal, just cause some annoyance. For instance, a person is standing on a carpeted floor. Initially his body is neutral. As he starts walking, due to contact and separation of his foot, slowly charge develops. After that, he is touching a doorknob or metal object. What happens, we all know, is a tiny electrical discharge, most often called ESD, and the person experiences an electrical shock. In a very humid day, we do not experience this kind of static charge effect, because water particle around us comes into contact and takes the charge away. When any object is charged, sometimes it is positively charged, sometimes negatively charged. It depends on the type of materials which are coming in contact or separation. For instance, human skin comes into contact with polyester material. Human skin gives off electrons and becomes positively charged. On the other hand, polyester receives those electrons and becomes negatively charged. Another everyday experience I should mention: if you rub a plastic rod on a wool or polyester, the rod becomes charged and can attract pieces of paper. Long time ago, a person named Abraham Bennett invented a device called gold leaf electroscope to detect electrical charge. This is a simple device, a metal disc connected to a metal rod, and on the other end of the metal rod, a thin folded gold leaf. If a charged object is brought near to the metal disc or sphere, the object is negatively charged and the electrons will be repelled from the disc and the disc becomes positively charged. On the other hand, the repelled electrons will move on the other end, and as we know that similar charges repel each other, the folded gold leaf now shows some separation. This is called induced charge effect. The closer the rod gets to the metal disc, the wider the separation. Nowadays, a solid-state electronic component called MOSFET can be used to detect static charge. This is the structure of a N-channel MOSFET, P-type substrate, and then on top there is a tiny thin layer of insulator. It is silicon dioxide insulator, and on top of that a metal layer is deposited. This is called gate, and on other two sides heavily doped N-type semiconductor is deposited, and one of these is called source and other one drain. When a positively charged object comes in close proximity to the gate, electrons are attracted from the deeper part of the substrate close to the gate, and this channel becomes more conductive. So now we can detect a tiny current flow from source to drain, and this can easily be detected. Similarly, a p-channel MOSFET can be used to detect negatively charged object. As this silicon dioxide layer is very thin, some charges leak through the barrier by a process called tunneling. In terms of electrical parameters, these are in the range of hundreds of megohms or several gigohms. The higher, the better. Here is the complete circuit diagram of the MOSFET electroscope, which can detect and distinguish both positive and negative charge. And this is the photograph of the implemented electroscope. Two small MOSFETs, one P channel and one N channel, are used. Gates and sources are connected in parallel. Only the drains are connected to two 3-volt batteries. On the gate side, two back-to-back Zener diodes are used to protect the MOSFETs. High voltage ESD discharge can easily damage the MOSFETs if these diodes are not there. The two MOSFETs that are used here, some of their electrical parameters are shown. We need low gate capacitance and very low leakage current for suitable operation. Both of these nearly fulfill those requirements. A small transparent plastic box bought from a nearby dollar shop is used as an enclosure. The top cover is used to hold the circuit board by one screw. And this is the red LED to detect positive charge, and this is the green LED to detect the negative charge. This is the P channel MOSFET, and this is the N channel MOSFET, and two batteries. These are 3-volt batteries. Top view and the front view of this electroscope is shown. It is better to connect the bottom part to a power ground so that any accumulation of charge on top or bottom plate will be removed. The best utilization of this electroscope is to detect human body charge. To understand better, we can bring in electrical model of a human body. The simple representation is a capacitor in series with a resistor. This is the body resistance and Cv is the body capacitance. In many textbooks, you will find a formula for calculating the capacitance of a sphere. This is 4 pi epsilon r, where r is the radius of the sphere. Our body is not a spherical shape. What we can do, we find the surface area of an average human body, then find out the radius of a sphere whose surface area is equivalent to that. Then we can calculate the capacitance of a human body. This is approximately 150 picofarad. This is a kind of model of human body with the values of the capacitance around 150 picofarad and the resistance which varies. From the middle of the body to fingertip, it is around 10 kilo ohm. When a negatively charged hand comes close to the top plate of the electroscope, the positive charge is induced on the top plate, the P-channel MOSFET will be activated, and this green light will be on. For positively charged hand, the red light will glow. The hand and the top plate forms a capacitance with a variable capacitance, that is Cx. For a charged hand, we can see that closer the hand to the top plate, the brighter the LED. Here is the plot of this distance versus MOSFET gate voltage for a typically charged human body. As the gate threshold voltages of the MOSFETs are around 2 volt. So at a distance of 4.5 centimeter, the MOSFETs are conducting, and we can see either of the LEDs can glow. Of course, if the body charge is higher, the separation can be wider. I am rubbing a plastic rod with a polyester cloth, and now we can see this rod is electrically charged and can attract paper pieces. This is the MOSFET electroscope inside part. MOSFET and 2 diodes, the switch, and 2 LEDs, back-to-back diodes, and 2 batteries. And you can see with one screw the whole circuit board is kind of attached to the top plate, and the source connection goes to the bottom side, and the gate connection is connected to this screw. And there is a aluminum tape is applied on top and on bottom, and this is the power ground line. It is better to connect on the bottom side, the source connected side, so that any accumulation of charge can go to the ground. So the switches should be on. There are 2 switches. This is used to prevent the battery to be drained out. So now it is ready to detect the charge. I am rubbing hand on a polyester cloth, and you can see my body is charged. So you can see the LED is glowing if I bring my hand closer to the top plate. And now if I bring the other part, the cloth, the green LED is on because the cloth is oppositely charged. And there are some charge accumulation, so the LED keeps glowing. Now a plastic rod is charged, and you can see that even the plastic rod can glow this LED. Now this plastic rod is wrapped with another plastic sheet, and you can see the now rod is negatively charged and the other part is positively charged.